Okay, so this is going to be the first of the grade 9 toolkit for math. First thing we're going to look at is the Algebra 1. So we're going to talk about exponent laws, power rules, and we're going to add, subtract polynomials, collect like terms, and do a common factor, and the distributive law. So a lot of things there, but we'll go through them here. So I'm going to do the exponent laws first, and the first law is going to be the product rule. But first of all, I think we need to know what exponents are. So for exponents, okay, exponents are that little number at the top right corner of a number. So if you see something written like 3 to the exponent 4, that means 3 multiplied by itself 4 times. Okay, so that's the same as 3 times 3 times 3 times 3. Okay, so 3 to the exponent 4 means that. The whole thing is called a power. Okay, the little superscript thing on the right is called an exponent. Okay. So that's what we're working with. Now, we know what this is. We've worked with it before. Can we figure out some rules that go with this? Well, the first rule we're going to look at is the product rule. Okay, product means to multiply. Okay, so when you multiply two powers with the same base, okay, so I forgot to write that down here, that the 3 here is called the base. Two powers with the same base, you can just add the exponents. So that's the rule. Let's take a look at maybe why. Okay, so let's look over here. X cubed equals x times x times x. Okay, x cubed times x squared would then equal x times x times x. That's from the cube part, these 3. And then x squared is x times x. So in total, we have 3 x's for the x cubed plus 2 x's for the x squared. And when you multiply those all together, we have 5 of them. So 3 plus 2 is 5. And we get the power x to the 5. Okay? So in general, x to the a means write x out a times. And x to the b means write x out b times. So you're going to have a total of a plus b of them. So that's our rule. Now, a couple of examples here. Let's look at this one. 3 to the 4 times 3 to the 5. The rule is just add the exponents. So it's going to be 3 to the power 9, or 3 to the exponent 9. 43 to the exponent 11 times 43 to the exponent 22 equals 43 to the 11 plus 22, which equals 43 to the power to the exponent 33. Okay? This works for negative numbers as well. You got to keep the negative inside the bracket though. It's a totally different thing if you take it outside the bracket. Okay? So I'm going to show you this quickly before we do example 3. Negative 1 to the power 2 is not the same as negative 1 to the power 2 with brackets. This equals negative 1. This equals positive 1. Okay? The reason this equals negative 1 is because it's a negative outside of the exponent. So you're going to do the exponent first. So 1 to the exponent 2 is 1. Then take the negative of that. This means multiply negative 1 by itself. Okay? So that is negative 1 times negative 1. A negative times a negative is a positive. This one is the negative of 1 times 1. Okay? So, we take a look at negative powers here. So negative 7 to the power to the exponent 2 times negative 7 to the exponent 3. Add the two together, you get negative 7 to the exponent 5. Put in an unknown, k to the 6 times k to the 9. Add the 6 and the 9, k to the 15. Okay. Next rule, quotient rule. When you divide powers with the same base, remember they have to have the same base, you will get a subtraction. Okay? You get A minus B. Okay? Here's part of the reason for it. 3 to the 5 divided by 3 to the 3. Write it like this. If you write it like this, 3 to the 5 is 5 threes. 3 to the 3 is 3 threes. If you multiply something by 1, as I've done here in blue, and by 1 again, it doesn't change it. So I can do that. Now, if we remember the rules for multiplying fractions, when you multiply fractions, it's top times top and bottom times bottom. So you've got 5 tops here and 5 bottoms now with these ones. You can break them up into 5 different fractions. 3 over 3 times 3 over 3, those two, times 3 over 3 times 3 over 1 times 3 over 1. Okay? Now, the 3 over 3's, they all equal 1. We say that the 3's cancel out. Okay, so you got 1 times 1 times 1. Doesn't do anything. Get rid of them. And then you got left with 3 times 3, which is 3 to the 2. Basically what you're doing is you're taking the number of 3's on the top and subtracting the number of 3's on the bottom. And that's what you get left over. Okay, so you got 3 to the 5 minus 2, which equals 3 to the 2. And so you end up with something like this. X to the a over x to the b equals x to the a minus b, the top minus the bottom. Okay, some examples here are 3 to the 7 divided by 3 to the 5. Subtract. You get 3 squared. Negative 7 to the 12 divided by negative 7 to the 3. Subtract. Negative 7 to the 9. Okay. 6 to the 19 over 6 to the 8. 6 to the 19 minus 8, which gives you 6 to the 11. G to the 9 over G to the 8. 9 minus 8 is 1, so G to the 1. Anything to the power 1 or exponent 1 is just written without it. So that's those two.